All right, so for the business calculus class, we're taking the Friday before spring break to do purely online, do a couple of video segments that solve some of the calculus differential equations we've been doing and some of the simple derivatives and then some implicit differentiation. That way you guys have the opportunity to watch these videos at any point you want, and these videos will also directly relate to the exam that's coming up the Wednesday after spring break. We'll take a practice test on Monday, we'll do the test Wednesday, and some of these problems will be the types of problems you'd see on the test. So I want to work some sample problems for you. Really, I'm working back through the whole section, but we're going to start in an area pretty quickly into the use of things like the product rule, the quotient rule, chain rule, and implicit differentiation. So we're going to move pretty quickly. I'll do the first one, I'll do real simple, and then after that we'll get more complex as we work through them. I'm going to do 2 at a time, and we'll do maybe 4 of these videos that are short, whatever length of time it takes to do the 2 problems. Now this first one, what we're going to do is find where the slope to this equation is 0. Right? Find out where this is 0. So we're going to take the derivative and set the derivative equal to 0 and then solve for that and find the values of x, which this particular function is 0 or level, minimums or maximums. So we're going to take the derivative. This is a really simple derivative. Everyone hopefully can see it immediately. This is 3x squared plus 6x minus 9. And then we're going to, and the 7 is 0. And we're going to set this derivative equal to 0. We're going to factor a 3 out. So that leaves us x squared plus 2x minus 3 equals 0. And this is factorable. So this gives us x, and we have a plus and a minus. We have 2 numbers that multiply together give us 3 whose difference is 2. And that's clearly the number 3. 3 times 1. So we have a positive 3 and a minus 1 because x times x is x squared. 3x minus x gives us a positive 2x. And then 3 times minus 1 is minus 3. This all equals 0. And now I can set these. Remember our principle. If we have 2 numbers multiplied together that equals 0, that means one of them has to be 0. We know 3 is not a possibility for us here. So we have to check these 2. So that means x plus 3 equals 0, or x minus 1 equals 0. And clearly this is x equals minus 3, or x equals to 1. So there are 2 solutions where at those values of x, we get a min or a max. We get a leveling off. This is a cubic. And so it clearly is oscillating, and you could plug these in and find at minus 3, is this our min or max? My guess is that minus 3 is a localized maximum and 1 is a local min, and then this thing takes off into infinity, positive and negative infinity this way. So we can find localized mins and maxes. At minus 3, you probably have a localized max, and at x equals 1, you probably have a local min. So this thing does that. And so that's the solution to that one. This one, we're going to do the same thing. We're going to take the derivative, set it equal to 0, and find out where do we have a local min or max. Now, we see here we have a different situation than this one. We actually have the product rule and chain rule both going to have to be used here. We have this function and this function. So y prime is equal to the derivative of the first, 2x, times the second, e to the 2x, plus the first, x squared, times the derivative of the second. Well, the derivative of e to the 2x is e to the 2x times the derivative of the inside. And the derivative of 2x is the number 2. So this is all, we'll clean this up. So do you see that? We have the derivative of the first. So this is f prime s plus f s prime. The derivative of the first times the second. The first times the derivative of the second. The derivative of the second is e to the 2x times the derivative of the inside, chain rule times 2. So this gives us 2x e to the 2x plus 2x squared e to the 2x. And on these problems, especially with the e to the x or e to the whatever the function is, it is really common to have something that can be factored very easily. And that's because of the nature of the derivative of e. Because e to the x produces a derivative of e to the x, when you do it in a product rule, you wind up where that particular term is in both parts of this addition. And so if we factor out, you see here, this will factor, we can factor 2x out, and we can factor e to the 2x out. And what we'll have left then is 1 plus x. And if we set this equal to 0, so e to the x is never 0. There's no x value to get that to 0. 2 will never be 0. We can get x equals to 0. We'll produce a 0 on this. And we can get x is equal to minus 1. So those are the two values for x by which this function goes level, that the tangent line is a slope of 0. So these are mins or maxes. Now, probably this oscillates somewhere around the origin. If you put 0 in there, you get 0. If you put minus 1 in there, you get e to the minus 2. So it's probably oscillating a little bit here in the middle, and then it runs off positive this way, and then it will ultimately go towards 0 in the negative direction, because this e to the 2x will dominate the x squared, and so this will oscillate up and then go out towards 0. But in the end, though, we found the min and max numbers on here. This is a localized minimum, and this is this is an ultimate minimum, and this is a localized maximum. This chart takes this kind of weird look. It goes from 0, it goes off into infinity, but right in here it does something like that at minus 1. There's some localized maximum there, and then there's a min at 0, 0, and then this thing goes off into positive infinity. So there's two problems there, both of them fairly simple derivatives. Set equal to 0. Find where these values of the tangent line slope is 0, and that will give us minimums and maximums. We can kind of see it play out in both of these problems. All right, so those are the first two.